For our last topic in the graphing module, we're going to go back to the trig functions, sine and cosine, and add a few more transformations. So just a quick review of where we were. We remember that sine graphs have this shape when they're positive, the Loch Ness Monster, and a negative sine graph would be inverted, like that. Things we already knew, that if you measure from the center line to the maximum or to the minimum, we call that amplitude, which we give the value A. We are working in radians, so usually our x or our theta will be in radians for this unit. And I also want you to remember that the period of a sine graph is the length of one cycle. So anywhere it repeats, so you can start measuring a period right here and follow through until you hit the same point. There's the length of one cycle. You can start measuring it up here at the top and follow it through until it repeats. There's one cycle, the length of one cycle. So for our standard graph, the period is 2 pi. And before we spoke about how exciting things happened every 90 degrees. So I'm going to change that from every 90 degrees, and I'm going to say that the key points happen in quarters. So what that means is we knew that if we took 2 pi, the period, and we divided it by 4, we end up with pi over 2, which is 90 degrees. And that stays with our thing where, every 90 degrees we're either hitting a maximum or a 0 or a minimum. But if we change the period, which is what we're going to do this time, the key points will happen at different x or theta values. And the last thing for sine is, if you forget the shape, just remember that it is a measure of y. So how much y contribution do you have at any angle? There's nothing when you're at 0 degrees because it looks like this. When you get up to 90 degrees, which in our Cartesian plane, there's a maximum back to 180. There is nothing, and then down to 270, there's a minimum. Our cosine graphs, the standard form, same thing, except we start at a maximum because it's like a measure of x. It's the same shape as a sine graph, it just starts at a different location, and that starts in air quotes for sure. You're just shifted over 90 degrees. So positive cosine graph looks like this. If it's negative, you're just going to flip it, and the shape of the graph will be this. Amplitude remains the same. We're still measuring the angle in radians. So the first thing we're going to add to our y equals a sine x is the variable b. Here I've shown the entire formula for all the transformations of sine. So that includes an amplitude change, a period change, a phase shift, and a vertical shift. So right now we're going to look at b, which I've drawn in red, and you'll notice that it's always kind of factored out from x minus c, and we'll deal with c in a sec, but right now we're just going to deal with b. So that variable represents the frequency, and the frequency of a graph is the number of cycles that fit in 2 pi. Looking over here, how many times, let's get 2 pi kind of illustrated, how many cycles do I go through between 0 and 2 pi? If I start here, it's a cos graph, I see 1 cycle. And then I see 2 cycles. So the frequency of this graph is 2. How do I find it? If I just want to do math, you take 2 pi and you divide it by the period. So there I was able to do it visually, but if I knew that the period, just looking at one cycle, it goes through an entire cycle in pi. 2 pi divided by the period, time for one cycle, equals 2, which is the frequency. So if a graph had a period of pi over 2, I do the same thing. 2 pi divided by pi over 2, watch your fraction math, is the same as 2 pi multiplied by 2 over pi. The pi's are going to cancel, and you're going to end up with 4. What does that mean? That in 2 pi, in 360 degrees, I'm going to go through 4 cycles, each one having a period of 90 degrees. Going the other way, what is a period of a graph with a frequency of 1/2? So we know that frequency equals 2 pi over the period. So we can just do some literal equation work there and end up with this equation. So it's always 2 pi divided by 1 to get the other. So if we want to know the period of a graph with a frequency of 1/2, 2 pi divided by, 0.5 or fraction math, and you're going to get 4 pi. That makes sense. That means that in 360 degrees, we only get through half of the graph, so it's going to take us 720 or 4 pi to get through the entire graph. Let's do a couple of examples where we find the frequency and period from an equation or from a graph. So looking at what I'll call number 1 here, there's a lot going on in this equation, and these are all transformations. This is a cosine graph that's had a lot of action. So be sure you know how to find your b value. It happens right here. So 6 is a number I'm concerned about. And I know that b equals a frequency, so it is 6. If I want to get the period, 2 pi divided by 6, reduce the fraction to pi over 3. So that means in 60 degrees, which is pi over 3, I'm going to go through 1 cycle of this graph. Now let's go over to number 2 here, and we're going to try and find the frequency and the period of this function. I don't care what the function is. I just want to know its frequency and its period. So in this case, I'm going to find the period first, because it's not pretty. Like, it's not starting perfectly at 0 and ending perfectly at 2 pi, or I can really see it. So just pick a good point. Like, I'm not going to pick something on the x-axis because of the labeling of the graph doesn't really tell me what this point is. So I'm going to go here instead. So I'm going to start at negative 2 pi, and I'm just going to follow the graph until I get through 1 cycle, back to the start. And that happens right here. Okay, so how long did that take to happen? Here's 2 pi. Here's another 2 pi. So my period is 4 pi. If I want to find my frequency, 2 pi divided by the period. Pi's cancel, and my frequency is 1/2. So the same as the other example, but perhaps harder to see. We've got A and B. Let's bring in C. So in our big, massive transformed equation, this is where C ends up. C is what they call a phase shift. That just means it's a horizontal shift. So it's how the graph moves left or right from its original position where it started at 0 degrees. So it's equivalent to the h in vertex form. We're calling that, ax minus h squared. So it's like that. Left-right shift. So if we look at this graph here, it started at this location originally and has been shifted to start over here. You have a lot of choices when you add in the phase shift, because it means you can start calling graphs different things. So I could have thought of this as, a positive sine graph that shifted this certain amount, has that phase shift, but you could start it and think it was a positive cos graph that shifted this amount. So it gets a little more interesting. We're not going to look at D, which is the vertical shift. So that would be if the entire graph had moved up and down and was rotating around a different center like this. But we don't have to worry about that. So let's look at a typical test question. They want the amplitude, the period, and the horizontal or phase shift for this particular equation. So then they want us to graph it. I'll deal with that in a sec, but let's get all the other things. Amplitude. has a value a. It's always in the front of the equation, and it is 2. So that is the amplitude. The period, I have to find from the frequency. So I know that b is also 2, and if I want the period, I divide 2 pi by b, and that gives me a period of 180, or pi. So that means it goes through one cycle in 180 degrees. The next thing I'm going to look for is the phase shift, pi over 4. Now notice that the equation is x minus c. So that means that the phase shift is positive. So we're going to start the graph at positive 45, or pi over 4. And we're almost ready to graph this. But what I want to think about is, well, first I want to put on my range. My maximum is 2 and my minimum is minus 2, and I got that just from the amplitude, up 2 from the center line, down 2 from the center line. I see that I have a sine graph, but where is the maximum? Like, I know I'm going to a maximum, but how do I decide? So the easiest thing to do is to take your period and you divide it by 4. So here that's pi divided by 4, which gives me pi over 4, or 45 degrees. So instead of exciting things happening every 90 degrees, exciting things happen every 45 degrees. So if I'm starting at 0, I know the sine graph is positive, so I'm going to go up to a maximum in 45 degrees. And then 45 degrees later, or pi over 4 later, I'll be back to 0. Another 45 degrees, I'll be at a minimum, and then I'll complete the cycle 45 degrees after that. So here is one cycle of the graph from the equation. I can continue that pattern, trying to hit that, so that should have been over here instead. And then likewise, I can continue it in the negative direction as long as I'm required to, or I want to, so on and so forth. What happens if I didn't know how to find, like I forgot what the graph looks like at 90 degrees? You can just use math, it'll work. So if you just take y equals 2 times the sine, sub in pi over 2 for x, because that's where we are on the x-axis. Do that math carefully, remembering that this is in radians, so you either have to have your calculators in radians to evaluate it, or you switch to degrees, and that will give you your next value. So you can always use your calculator, but it's just faster to know what the graph should look like. Interesting thing to observe here, we have this sine graph, but I notice that I'm at a minimum at 0. So there is another equation that describes this exact same graph, and it's a negative cos graph. So if I had that cos graph, the amplitude would be the same. It's a cos graph instead of a sine graph. It's negative. I'll just try and sneak that in the front. The period is the same, but I have no phase shift. So these two equations are equivalent. Here comes another one, just the same. Amplitude, period, and phase shift from the equation. So starting with the amplitude, my amplitude is 4. Notice I didn't write negative 4, because a negative just kind of describes whether the graph is inverted or not, or reflected. You usually just keep the amplitude as a positive number. Going to the period, I see that the frequency is 3, therefore the period is 2 pi divided by the frequency, 2 pi over 3, and I'm just going to leave it like that. The phase shift, I see that it is positive, which tells me that it had been x minus pi over 6 to make that situation true. So my phase shift is negative pi over 6, which is negative 30 degrees if you need to think about it in degrees. So that's the first part of the question. Now we need to get ready to graph. Looking at the divisions on this graph, I see I get to pi over 2 or 90 degrees in 3 blocks. So each one of these little things is pi over 6 or 30 degrees, and I'm going to start at negative pi over 6. My maximum is 4. My minimum is negative 4, just from the amplitude. I'm going to put some dot dots so that I don't miss my targets. And now I need to find out where I'm going and when I get there. So the first thing I'm going to change is that this is a cosine graph, and it's a negative cosine graph. So should I have started by putting my dot on the x-axis? Nope, I should have put it down here. So the graph is going to start at a minimum, because that's what negative cosine does. So a little bit of a correction there. The next thing I need to decide is, when do the key points happen? So the key points happen in quarters. So take your period, which is an entire cycle, and divide it by 4. And you're going to get 2 pi over 12, which equals pi over 6. So once again, we're getting that thing where it's not too hard to graph, because our action happens in 30 degrees and we started 30 degrees away from the x-axis. So negative cos, we started in a minimum. 30 degrees later, we go through 0. 30 degrees later, we're at a maximum. 30 degrees later, back to 0, and so on and so forth. Hopefully not messing anything up. So I'm going to draw that graph, making sure when I start it's a negative cos. Okay, I'm happy with that. You see that high frequency playing in. Okay, same situation as last time. When I look at this graph, I'm like, oh hey, when x equals 0 on the y-axis, I'm actually at a key point for another graph. So what could be a different equation for this? A sine graph, but here it's a positive sine graph, so I say 4 sine. Don't mess with the period or the frequency. 3x, and then you don't need to deal with that phase shift. This is a super important point. Sometimes the phase shift is hidden. So if you see a graph like this, and you remember that I told you, let's do a cos, sorry, and then it's cos b onto x minus c, and we're not dealing with the d, with or without extra brackets. So looking at the form that's given to you and looking at what I see here, the x is not by itself within brackets. So that means I need to factor out the 3, because the left side up here is not the same as this right side, because the 3 would come out of both terms in brackets. So if you're given a graph that doesn't have the b value factored out, you must factor it out in order to see the phase shift. So you're going to take both terms and you divide them both by 3, and suddenly you see, yes, the b value is still 3, but the phase shift is not pi over 6, it's pi over 18. So looking at this graph, we're going to clean it up before we go any further. We start with y equals negative 2/3 sine 4, and we factor out the 4. It leaves x plus pi over 4. So our phase shift wasn't 180 degrees or pi. It's actually 45 degrees or pi over 4. All right, now we can proceed. The amplitude is 2/3. Remember, keep that absolute value. The period is 2 pi divided by the frequency. Sorry, the period is 2 pi divided by the frequency. The frequency is 4, and I'm just thinking ahead here. 2 pi divided by the frequency, which equals 90 degrees. So 1 cycle in 90 degrees, or 4 cycles in 2 pi. All right, back on track here. And looking at the phase shift, it's positive in the equation, which means it's actually a phase shift to the left, 45 degrees. So what type of graph? It's a negative sine graph. So I can start on 0 this time. So I know my starting point will be negative pi over 4, which is right here. I'm just going to arbitrarily call this positive 2 over 3, and this is going to be negative 2 over 3. So there's my range. And I need to think about when the key points happen. So I'm going to take pi over 2, which is a period, and I'm going to divide it into quarters by dividing by 4, which means pi over 8. It's going to be a very tight graph. Okay, so this is going to be very approximate. So if I am going to start, and I'm going to make a negative sine graph, I'm going to have a minimum right about here. I'm going to be back to 0 here. I need to think about where I need to go. A maximum, say, here, back to 0 here, a minimum here, and by pi over 2 I'm there. So that is a tight graph. And mostly you'll just be expected to match graphs, but if it was old school and you had to draw it, you'd be drawing something like this. And once again, this could have been called something else. And that would have been a positive sine graph. Another name for it. One more where we have to factor out that b value to see what's actually going on with the phase shift. So clean up the equation first, hopefully not with a highlighter. Y equals 5 cos. Factor out the 1/2, leaving x plus pi over 2. Excellent. All right, amplitude is 5. I'll go put that on. There we go. There's my range in the positive direction. There it is in the negative direction. Thereabouts. Okay. The frequency is 1/2, which means the period is 2 pi divided by 1/2, which equals 4 pi. Big graph. And then now that I've done this factoring, I'm going to take my, don't look to the original equation, pardon me, look to the one you factored out. My phase shift is negative pi over 2. Because it's at x plus pi over 2, I know it must be x minus negative pi over 2. All right, so if I have a graph where things happen in key points happen in quarters, I'm going to take my period and divide it by 4 to find out when I get those key points. Everyone hate 80 degrees. All right, that's fine. So let's start making the graph. I need to start at negative pi over 2. And I need to start at a maximum because this is a cosine graph. It's going to take me 180 degrees to get my next key point. So I only hit a 0 at positive 90 degrees. I only hit the minimum at 3 pi over 2, positive 270. This is a really spread out graph. Maybe I'll put one more point over here. And just letting that happen. That's because the period is 4 pi. It's just going to be a Mondo graph. There we go. We also need to be able to take a graph and find an equation from that graph. So here we go. I'm going to look at this graph and I'm going to figure out what the shape is. Well, this one's great. It starts at 0. So I'm going to pick the one that starts at 0 because that means I don't have to deal with the horizontal shift. When do I get through one cycle of this graph? When do I get back to the start? Right here. What's the maximum, the minimum? 3 and negative 3. So I have the information I need at this point. So let's start by writing y equals, is it a normal sine graph or an inverted sine graph? It's normal, so I put the amplitude, the shape of the graph, starting at 0 is a sine. Now I need the b value, which I don't have yet. I do see that the period is 6 pi, so I know that in order to find the frequency, or the b, I divide 2 pi by 6 pi, and that's going to give me 1 over 3 when I reduce it. 1 over 3 x, and I started at 0, so I don't have to add that shift in. There's your equation. Here's another example. I doctored into radians because it was given in degrees, and let's go through. So we're just going to list ABC this time. I see that my range is between 4 and -4, so that means my A value, my amplitude is 4. My B value, so I need to do 2 pi over the period, so let's go over the graph and find the period. Find where it starts. I'm actually going to take the 0, 1 because I can see kind of that I'm getting to this point maybe right here. And it was hard, but the period remained 2 pi. So that's great. That means my B value is 1. Do I have a horizontal shift? Sure. So I've got to decide where I want to start this graph. Do I want to make it a sine graph starting here? Or do I want to make it a cosine graph starting here? I'm going to pick the cosine graph. I usually personally like to pick the graph that starts closest to 0. So that would be a positive cos graph. So I'll write that down too. And I will decide that my horizontal shift is pi over 6. So let's put it all together. We're going to have y equals amplitude, graph type, frequency is 1, so I don't have to write it down because it's implied, and then x and our phase shift, x minus phase shift. Done. Leaving the best for last, I've given a graph and I want to find both the sine and a cosine equation. So I'll start with the sine, and I'm going to pick a sine curve, positive or negative, that is closest to 0. So I want to start it right here. And it's hard to see from this, but this time the divisions are actually 4 divisions to get you to pi over 3. So if you're curious as to what those individual divisions are, you can always be like, okay, I got to pi over 3 in 4 steps. So each little tick mark that's hard to see will be pi over 12. So just knowing that. All right, so let's think about the shape. If I start at this point and I go down, that is a negative sine graph. My amplitude is 2. My period, all right, let's go to this point, the y-intercept, and just see when we get to the point where that happens again, where we start to repeat the cycle. I go all the way along, and here it is. So I know that my period is 2 pi over 3, which means if I want to get my b value, I have to do 2 pi divided by 2 pi over 3, which is going to be 2 pi times the reciprocal, 3 over 2 pi. Those will cancel, and the b value is 3. So a lot of work for a nice integer. The horizontal shift is 1 unit over, so that's pi over 12, negative pi over 12. The equation, y equals negative amplitude, shape of graph, brackets, frequency, x minus the phase shift, so x minus minus 12 is x plus pi over 12, sorry, not minus 12, pi over 12. So there's the equation as a sine graph. So if I want to find a cosine graph now, it's not hard. I just have to find where a cosine graph happens closest to the y-axis, and that's right down here. And that point is pi over 12, negative 2. So if I'm doing a cosine graph, it's also a negative cosine graph. The amplitude remains unchanged. So this part just changes the word. The frequency remains unchanged, and the phase shift is positive pi over 12. So x minus a phase shift. There we go. So sine graph and cosine graph. That's everything you need to know for the graphing unit.